Welcome. Yesterday we worked on learning the back side of our ratios and proportion notes where we were studying similar triangles. And when we were doing that, we were marking corresponding sides. So on this first triangle, we said that this side that connects with the right angle was the same or similar length as this side. So we marked those with a little 1 hash mark. The longest side, the hypotenuse across from the right angle, we marked as a 3 because it was the longest side on both. We did that because then when we're given numbers and comparing sides, we know how these triangles may line up. For example, in this example in our notes, we have what looks like it could be almost a right angle. Across from it is definitely the longest side, the hypotenuse. So we know that this side, if these two are similar, this x, 1 hash mark, is similar to this one, the 10. Now, how did we know that these two are similar? Well, we could have given you the names of the triangles, but for simplicity, since we didn't give you a number here and here, we're going to assume that those two are similar and that Ms. Hoffman and Mr. Benson are not trying to trick you. So when we set this up, we are always going to say that the first triangle side compares to the second triangle, and that the second first triangle side compares to the second triangle. So let's highlight our triangles maybe so we don't get confused. So let's go yellow triangle here, and that's first triangle, both sides, and green triangle over here, so that's second. So again, number-wise, I am going to compare 50 on the yellow triangle to 5 on the green triangle. Again, I'm going to start with the first triangle and I'm going to compare x to 10. So I could write that out again as a fraction. 50 is to 5 as first one is x is to 10. We're going to cross multiply. Cross multiply. And then remember we have to do the opposite when we're solving for x to get x alone. So this says 5 times x, so we're going to divide both sides by 5. That cancels and leaves x alone. But what you do to the left side, you have to do to the right side. So 500 divided by 5, I use my calculator, and that is 100. So let's look at a worksheet where we do similar things. Here's a worksheet that'll be similar to one that we do this week, where we're given sides. This time we're given all 3 sides, and we're given 2 sides over here. Well, let's just assume that this side 10, now let's start with the longest side, this hypotenuse. Definitely these triangles look similar. We are going to assume that they are because it says here they're similar. So I'm going to put 3 hash marks here and 3 here. I know that 11 and x are the same. So again, I'm going to start with first triangle, 11, over second triangle, x. And then I can choose any side I want. I'm going to choose this bottom one here, 18. And that looks similar to this one, 126. So again, first triangle, 18, over second triangle, 126. I'm going to cross multiply. I'm going to cross multiply. Again, I need to use my calculator. Big number, 1,386. Again, 1,386. $18 times, so I need to do the opposite. Remember, we're always typing in first number, top number in our calculator, divided by bottom number, x equals, I don't want to give away the answer, but that's how we do these. let's move on and look at one more, see if there's any confusing ones on here. All right, on the second sheet, there is some real life applications. That's part of our learning target. We are going to assume that this triangle, and I will outline it in blue, the height of the building. Maybe this is a fire hydrant over here. So the building to the fire hydrant, or sometimes this in an ACT question is a building casts a shadow. And then on this other triangle, let's go orange. The height, the shadow, and then the distance there. I see that this is the longest side. I'm going to mark it with 3 hash marks. This is the longest side. I'm going to mark it with 3 hash marks. So I can start by setting up my problem. First triangle, 56, over second triangle, 28, equals, what am I looking for? Oh, there's a blank line over here. Let's call this x. So let's call this side, this is the same height as this, so I'm going to just mark it right here. This side compares to the 7, because I know the 7. But what goes on top, 7 or x? That's right. First triangle over second triangle equals first triangle over second triangle. X goes on top, 7 goes on the bottom. Again, we're going to cross multiply. 28x equals, and then we'll multiply those two. This is an equals, not a 2. One more I want to kind of explain below. On number 6, it looks a little confusing. So what Ms. Hoffman and I do is take this triangle, this big one, in blue. I'm going to recopy it here. I'm going to take this little triangle in green. That's blue. In green. And I'm going to recopy it here. That way I don't get confused by all the numbers. Again, this side right here is similar to this side right here. And I know the numbers, 20 and 6. Now I'm given this length, 36, but I have no idea what this is. I know that this little part is 36, but not the whole thing. That doesn't help me. I know that this little part is 24, which means I know this little part is 24, but that doesn't help me. So I only know one side of this triangle, and they want me to know QT, this whole thing. So this is going to be a two-stepper. First, I'm going to find the length of this whole thing. What do you mean, Mr. Benson? I mean, I'm going to find the length of purple. How are you going to do that? Well, it's weird I'm talking to myself. I'm going to say I know 20 and I know 6. So I'm going to say 20 in the first triangle is to 6 in the second as, if I want to know this whole thing, I wonder if I should use this side down here. So 24, that's in the second triangle, so it's got to go below. And this whole thing I don't know, so I'm going to call x. So when I solve this, I will know the length of Q all the way to T. And that's how you do it when you have a triangle inside a triangle. Have a good day.